So the goal of this webinar is to present an understanding of the opportunities the IP-A1 network PA system can deliver and the key features of the system. So I will start with a table of content. Number one, I will go over the overview and importance of a network PA system. Then we will go over the IP-A1 series lineup and key features, useful and unique functions, then integration types, and we will end with application examples. So before we start developing the network PA system, our new IP-A1 system, we ask ourselves, like, why we need a network PA system? And actually, this one led us to main 4 questions: what, when, where, and how. So the answer of the first question was the content, the live messages, the pre-recorded messages, and alarm messages. So what we want to deliver. So when is all related to the trigger. So either it can be via IoT sensor, signal sensing, or HTTP commands. So where we want to deliver this content, so it can be either individual speakers, areas or zones, or even group of zones. How? So we have many means to do it, either paging microphone, SIP phone via SIP server, or even VMS integration via OnVIF. Of course, all of these can be with priority and volume control. So to go over this IP-A1 system, I would like to start by saying it is a serverless audio management system, which means we don't provide the server and we actually connect to third-party SIP servers. We utilize SIP protocol as infrastructure and obviously SIP devices. The IP-A1 is able to deliver instantaneous voice-assisted responses. Also, it provides high flexibility configurations and system expansion capabilities. Because of the simplified cabling structure, it is a cost-effective system because it lowers the labor and material cost. This system can be also integrated with other building services and subsystems. More details will come. So, how the network PA system can actually simplify a PA system in general. In traditional PA systems, we need a remote microphone, program timer, sound repeater, and PA amplifier to actually perform the paging function. While with a new IP-A1 system, we can do pretty much everything with one device. With one IP paging microphone, we can do individual and group broadcasting, and also we can schedule an event, so we can do scheduling with end events. Plus, also we can connect music sources as BGM directly to the microphone via a line input on the microphone itself. So actually we can do pretty much everything from a paging microphone. Of course, it's in simplest form. One additional function that the paging microphone can do is after recording the content, you can check it before transmitting using rehearsal function. So why a network PA is important? Actually, the network PA system provides many benefits to the end user. Here, I would like to mention 2 of them. Number 1 is individual broadcasting, which is not easy to accomplish with analog PA system because it will occupy a lot of channels on the amplifier. With the network PA system and via the SIP protocol, we can do SIP individual broadcasting to speakers. The second main benefit of a network PA system is integration. With the right VMS system and CCTV cameras, we can actually integrate the network PA system by sending HTTP commands to run specific pre-recorded messages to a specific audience. For example, if we have a woman in her 30s, we can send an HTTP command to run a specific pre-recorded message targeting her by, for example, saying a limited time discount for certain products. Again, with the video analytics and CCTV cameras, we can also target different group of people by sending different HTTP commands signals and running different pre-recorded messages. At the same time, if there is a stranger or intruder and the video analytics capture this, we can send a specific HTTP command to run an alert and emergency message to specific zones as well. So I would like to go over the lineup and the key features of this IP-A1 series. We divided our IP-A1 system into mainly two main columns, the broadcasting terminals and the receiving terminals. I already mentioned about the IP remote microphone, which is the first broadcasting terminal. This microphone actually comes with an LCD. It can do SIP calls to SIP servers or peer-to-peer SIP calls. It can do multicast audio streaming, scheduler for audio file broadcasting, event broadcasting by contact input. The microphone has a contact input built in, and also auxiliary input for background music. So all of these features can be done on the microphone. More details will come also later on. The second device that we are providing is called the paging gateway. The paging gateway is similar to the IP remote microphone, can do similar functions, but also additional functions as well. So the similarity comes when we are talking about scheduling for audiophile broadcasting, event broadcasting by contact input, and also auxiliary input for background music. The paging gateway will provide additional functionality such as converting the SIP or ONVIF or auxiliary input to multicast streaming. And also, it provides priority control over the broadcaster's devices. So in case we have paging microphones, more than one paging microphone, or combination of paging microphones and SIP phones, the paging gateway will do priority control over these devices. So these are the main two broadcasting terminals that we provide. Now, in terms of receiving, we have two types of products. Either it's a speaker or either it's a box that can do something different. So in terms of speakers, we have two types of speakers. For now, more are coming soon as well. We have the IP ceiling speaker and the IP horn speaker. The IP ceiling speaker, it's an indoor speaker. It has an 8-watt output and also an internal memory of 80 megabytes where we can save up to 20 messages, pre-recorded messages, and we can run those with different applications. Also, it has two contact inputs and one contact output, while the IP horn speaker has 15-watt output with max SPL at 124 dB. It's powered with PoE Plus and also has an 80 MB internal memory for 20 messages and multiple broadcast modes. The two other devices are actually IP audio interface and IP zone amplifier. The main difference between the IP audio interface and the zone amplifier is the impedance of the speaker that we'll be connecting to. So the IP audio interface will connect to low impedance speakers, and the IP zone amplifier will connect to high impedance speakers. The IP audio interface has a line output and control output to allow a connection to local amplifiers. It has 15-watt low impedance output. It has a line and mic inputs, but either one of them can be enabled at a time. And also it has an 80 MB internal memory for pre-recorded messages. While the IP zone amplifier has 12-watt high impedance output, can be 170 or 25 volt, has line and mic inputs, which only one of them can be enabled at a time, has also an internal memory of 80 MB, 2 contact inputs and 1 contact outputs. Now, what are the functions that each device can provide in more details? So each device will bring useful and unique functions. I will start off with the IP audio interface. The IP audio interface mainly has 3 functions. The first one is working with a local amplifier. So actually, because the IP audio interface has a line output and contact output, we can connect the IP audio interface to amplifiers to send messages, emergency alarms, or normal paging messages to high-powered speakers. I can give an example of a gym, for example, where high-powered speakers are needed, an amplifier eventually. Then in this case, we can use the IP audio interface with the line output and contact out in order to deliver paging signals over to these speakers. The second function is actually working directly with low Z amplifiers and low Z speakers and connecting the low impedance speaker directly to the IP audio interface, which has to be maximum 15 watts in order to get the maximum wattage. And this will work as like standard function. The third function is actually using the IP audio interface as a standalone mini amplifier. So in case you have a low impedance speaker with a music source, you can connect through the line input directly the music source to the IP audio interface and use it as a standalone mini amplifier. And of course, the IP audio interface has to be powered by TOA. Now, the IP power amplifier has also 3 main functions. Some are similar to the IP audio interface. Function 1 is actually using the IP amplifier as a zone amplifier. So in case you have a project where you would like to use analog passive speakers, or you have a retrofit project where you want to keep your analog passive speakers, you can do so by adding an IP power amplifier, but please make sure that you don't connect more than 12 watts per IP amplifier, and you can create zones with the IP power amplifier. Again, the IP power amplifier can accept output 100 volt, 70 volt, and 25 volt. The second function, which is actually interesting, is sharing the PA speakers. So if we would like to share the passive analog speakers that they are connected actually to an amplifier, it can be voice alarm amplifier, we can insert the IP power amplifier in the middle. And we can use the same speakers to do paging. And at the same time, if we need to run an emergency message from the main amplifier to those speakers, the amplifier can recognize priorities. So there is a switcher, a speaker switcher inside the power amplifier and the speaker input on the amplifier. So we send a speaker output from the main amplifier to the IP power amplifier, then another speaker output from the IP power amplifier to the speakers. And there is a switcher embedded inside the IP power amplifier, and this switcher will actually activate in 4 cases. In case the power goes off, then the IP power amplifier will immediately switch to the main amplifier. In case there's a higher priority signal, should be treated. Or in case the contact input get enabled, which actually is the contact input is coming from the main amplifier, or even if the amplifier, the IP power amplifier, turned off. The third function is actually using the IP power amplifier as a standalone amplifier. So in case we have analog speakers, passive analog speakers, and we have music source, we can connect this through the line input and use this IP power amplifier as a standalone mini amplifier. The next product is the IP remote microphone. So the microphone has mainly 4 functions. The first one is peer-to-peer and group broadcasting. We already mentioned this, but the microphone can do SIP peer-to-peer or multicast broadcasting. The second function is the 20 channel. So there is a 20 channel on the microphone. On the microphone itself, there is 10 buttons. And we can switch into 2 pages. So page 1 will have 10 functions through these 10 buttons, and page 2 will have another 10 functions also through the same 10 buttons. So we can assign to each button or key the one of the following: either multicast broadcasting, individual broadcasting, internal sound source playback event, or sending HTTP commands. So we can do either or for each key. Third function is actually the scheduler. So we can control when to broadcast by utilizing the scheduler. It can be chime, sound source. Sound source means the pre-recorded message, the internal pre-recorded message, the BGM, or the line input. The fourth function is the rehearsal function I already mentioned. So you record, check, then you broadcast. Now, the IP paging gateway has different set of functionalities. It has mainly 3 functions. The first one is actually converting the signal, the incoming signal, into multicast. So if we connect the paging gateway to a VMS, we can convert the on-VIF signal into multicast. The same if we connect the paging gateway to a SIP phone or a SIP server, we can convert the SIP to multicast. The same if we have internal message built inside the paging gateway, we can transmit these into multicast streaming. Also, if we have a line input connected to the paging gateway as a BGM, we can also convert these into multicast. The second function, which is similar to the microphone, is a scheduler. In addition to the main functions I already explained to the microphone, it's possible also to schedule of sending multiple HTTP commands all at once to different locations. The third function is actually priority control. If we have more than one paging microphone or a combination of paging microphone and SIP phones, we need a paging gateway to do priority control. Now, what are the type of integrations that we can do with our IP-A1 system? Actually, IP-A1 system, as we explained, can be integrated to the VMS or a SIP server. The VMS integration will happen through on-VIF. So on-VIF, it's a protocol where it supports audio back channels, so we can send on-VIF signal to the paging gateway to convert these into multicast, which actually we are adding a multicast capability, which is group broadcasting to the VMS. And the supported VMS as of today, but our headquarters is working hard on adding more VMS. We support 5: Genetic, Milestone, CBC, WaveStore, and Avigilon. So the second functionality that we can have through this type of integration is HTTP commands. The VMS can send the paging gateway HTTP commands in order to run certain events or to multicast stream the pre-recorded messages on the paging gateway itself. So this type of integration will actually allow the user either to use the microphone connected to the VMS to do multicast streaming via on-VIF, or to send HTTP commands to the paging gateway to do a different set of multicast streaming. The second integration is pretty standard, is the SIP server. So we have SIP phones and also SIP soft phones. We connect all these and register those to the SIP server. And also we can add the paging gateway and we register the gateway to the SIP server. And the gateway will have an extension number in this case. So via the SIP server and the paging gateway, we can do multicast streaming from SIP phones. Again, a SIP phone can do multicast streaming directly if it's connected directly to the paging gateway, but a SIP server is required for a different set of functionality. In addition to VMS and SIP server integration, the system can work in standalone mode. There's mainly three options where the system can work in standalone mode, and the simplest one is having one paging microphone and one paging microphone only. So if you have a project where you need just one paging microphone and multiple IP speakers or IP devices like the IP audio interface or IP zone amplifier, you just need one IP paging microphone to do individual and group broadcasting, peer-to-peer multicast. Now, if you have a SIP phone and the project requires a SIP phone instead of a paging microphone, you can do so by adding a paging gateway. So the paging gateway will handle the SIP to multicast conversion. Now, the third option is if we have multiple microphones or combination of microphones and SIP phones, then you need a paging gateway to do priority control. And of course, to convert the SIP into multicast at the same time. So now, after we explored the integration types from VMS integration to SIP server integration to standalone applications, I would like to go into the application examples of this system. This system can be installed in any small to mid-sized project, but here I will be focusing on the education system, education market, sorry. So in general, if we have a school, we have different type of rooms. We have classrooms, we have the principal office, we have the secretary desk, we have the gym, we have multi-purpose room. So in each of these rooms, we need different set of products and functions. In classrooms, we can install either IP ceiling speakers or we can install analog speakers, but in this case, we need to add either an IP zone amplifier for high impedance speakers or IP audio interface in case we have low impedance speakers. In the gym, because of the nature of the gym, we need high powered speakers, and thus we need an amplifier, local amplifier. In this case, we only need to add one IP audio interface, and we connect the line output with the contact out to the amplifier to do paging. In multipurpose room, we can add passive speakers with IP zone amplifier in case those speakers are high impedance, or IP audio interface in case those speakers are low impedance. Now, in the principal office, mainly we will have the SIP master phone and the VMS client on the PC. And on the secretary desk, generally we have a paging microphone. Now, outside, we shall install the IP SIP horns and CCTV cameras. On the doors, on the entry doors, we will have door stations. So how this one will translate into a diagram, a real project diagram, we will have a SIP server. All the SIP devices will be connected and registered to the SIP server. We will have one paging gateway to connect to the SIP server and also will be registered to the SIP server. And all other IP devices will be connected to the LAN and registered to the SIP server for individual broadcasting from the SIP phone. The paging gateway will handle the multicast streaming. I would like to highlight that if you need to have more than one multicast streaming at one time, you need to install more than one paging gateway at a time. So if you want to do two paging signals to two different zones at one time, you need two paging gateways because each paging gateway will handle one multicast stream at a time. The second here example, it's just an example to show the integration that I was speaking about with the IP Power Amplifier. So in case we have a voice alarm system in the staff room, and we have a high impedance output, 25 volt, 70 volt, or 100 volt output, we can connect this directly to our IP power amplifier, and this will allow the emergency alarm to override in case of emergencies. The IP power amplifier, as explained, will do different functions at the same time. So the IP power amplifier will connect the classroom to principal room via the RS-160, the call button, and the microphone. And also the IP power amplifier will receive multicast streaming from the paging gateway. The third example here is having multiple paging gateways in the project. As I explained, if you have multiple paging microphones and multiple subphones in the project where you need to do multiple paging at the same time, you need to install multiple paging gateways. In this case, the paging gateway will handle all the multicast streaming, the conversion from SIP to multicast, and the priorities. So it will define which SIP phone will be allowed to page, and we need a SIP server for individual broadcasting, for SIP peer-to-peer broadcasting. The last example I have here is actually the VMS integration. In case we have one of these 5 VMS softwares installed in the project, Genetec, Milestone, CBC, Wavestore, or Avigilon, we can do multicast streaming via ONVIF protocol, and this will be handled via the IP paging gateway. So this can be done directly from the VMS. And also, as I explained before, the VMS can send HTTP commands to the paging gateway to run certain set of pre-recorded messages to certain areas. Now, if your VMS is not one of these 5, then you need to use our IP remote microphone for paging and multicast streaming. So, in conclusion, the IP-PA systems are becoming more prevalent, and integration with other devices and systems are essential. IP-A1 series will allow for various configurations and integration options, such as VMS, subserver, and also standalone operation mode. The IP-A1 system will provide useful features which can be applied to various market facilities. I would like to thank everyone for listening, and now I will be open to hear your questions. Okay, thank you everyone for your questions. I will go now one by one, and I will start with the first question. Which CCTV cameras is this fitted with? So mainly speaking, we support 5 VMS systems as of today, and any CCTV camera can connect to this VMS we will be able to work with. So basically the integration is through the VMS itself, not the camera itself. So it's all related to the ONVIF and HTTP integration between the VMS system and our IP-A1 system. So the second question was, how would you deal with a shared school where there are shared speakers used by different people at different times? It would be a school application. So in general, the paging gateway will manage priorities. So if we have more than one paging microphone or a set of combination between paging microphones and subphones, we will define by priorities which one will pass first, then second, then third, etc. So these priorities will be set on the paging gateway, and we need to configure the paging gateway on the priorities. Now, if you have let's say multiple schools that are trying to connect to each other, this is something like not doable unless you have a one LAN. So if the device, the paging gateway, can see all microphones or SIP phones are on the same LAN, then this won't be possible. So once we have all the devices, let's assume you have a way to do it, like via VPN or something, and you have all devices on the same LAN, it all will be through priorities. So for example, if you want to page from school 1 to school 2, and they are all on the same LAN, then the microphone in school 1 will have higher priority to override the second microphone that is in the second school. I hope this is your question. If I understood your question correctly, that's great. If not, please, you can clarify your question. The second question, the third question is, how are the output contacts controlled on the devices you have presented? Are they engaged when the device is active, or can be programmed to respond to a certain input, like an extension from SIP phone? No, it will be programmed to respond to certain input. So for example, if we have a call from certain extension, you can assign the contact output to be triggered. So this can be programmed. The next question is, can you trigger emergency strobes, lockdown, for example, and a recorded message with one button push? The answer is yes. We can create an event once we receive a contact input on contact input number 1, for example, which is the push button. Then we can activate the contact output, and we can run the event, which is the pre-recorded message number 1, for example. So the answer is yes. Now, the next question is, apart from schools, what other types of building do you see this PA being useful? Well, this system can be installed in any application that it's like mid to size project. Small to mid-size project. For example, factories. It can be a small airport installed in retail stores. Like in retail store, this will be very useful because we can do multicast and individual streaming plus events. So retail stores will be a very big part as well. What is the limit on the number of paging gateways in a system? Same question for IP paging microphones. Now, I don't have a set fixed number. Like virtually, it's unlimited. But I will double check this one, and I will come back to you about this one. Virtually, the answer is unlimited. Number of paging gateways and paging microphone.